One of the things that I know that has happened throughout the day today and course of yesterday was that some of you guys were getting distracted by one of the segments in here. Before I do that, I'm going to go through what you're given to start with, just like you should always when you're working with these things. First things first, you write down what you know. Angle N is congruent to angle P. Then I would go and mark it. Now, I know your diagram was already marked, but it's not a bad idea just to kind of over darken it so you can know where things are lining up. Excuse me. Go to the next one, MO and QO. And go back and tick mark it. Now, a lot of you guys at this point, from when I was helping people yesterday or this morning or even the other two classes, a lot of you guys were saying something now about MQ. Oh, that's a shared side between something. It is, but it's not with anything you're trying to do. So my suggestion, when you get to a point that you're not exactly sure where to go next or what else might be there that you have to mark up, because if you start going through the four things that you know, we know a side and an angle. We know one side and one angle. So we know we can not have to worry about side, side, side. We could have side, angle, side. We could have angle, side, angle. We could have angle, angle, side. It now depends on what the next thing you find. So what I would do, and I hope that you guys are starting to think about this, is trace the triangles they're trying to have you prove. Just darken them in a little bit with your pencil. By shading over the lines of the triangle that you're trying to work with, then your eyes get drawn towards them. So now you'll see that you have what around angle O? Or vertical angles. Yeah, that's the idea. If you're not exactly sure where to go next, you're not sure what you're trying to look for, trace over the triangles they're trying to have you prove, because a lot of times that'll help you figure out, is there a reflexive side you're trying to find? Is there vertical angles? Is there something else that you're missing? Okay. So now you'll notice you've got vertical angles, and you would say angle MON is congruent to angle Q, I gotta go the right order, QOP, because vertical angles are congruent. And now you have two angles on the side. You have two angles on the side, so is it angle, side, angle, or is it angle, angle, side? Very good. It's angle, angle, then the side next to it. So your triangles are congruent. There you go. There was no progression on that one. Bless you. All you had to find was that extra vertical angle side. And the trick on that one was to literally just trace over it and see what you can match up. Okay? Does that help on that? Tracing on a lot of these things helps a lot. Second one. And angle FJG is congruent to angle HGJ. Of course, they have to use the letters that are just kind of the most annoying to write down and say. Thank you. Okay. Trace the angle. You're at angle FJG. So you start at F, you go to J, go up to G. So FJG. So that's this guy here. The match HGJ is that guy there. Excuse me. All right. So we can write them out. Go to the next one. And what was the trick that I was telling you guys yesterday about with parallel? Yeah, in this case, it's a picture of the Z, because you know that these two guys are parallel. So trace the Z. Where it changes direction, where the Z changes direction gives you the angles that are congruent. All right? Where it changes direction are always the angles that are congruent. The what? Sorry? Oh, but look, those are angles on this side, not in between. This is the other side. These would be congruent if those sides were parallel. It's the end now. So in this case, it's this set that are on the inside of the Z's that work. So you get angle F, F, G, J, and then H, J, G. And this is that longer one to write out. If two parallel lines are cut by a transversal, and alternate interior, angles are congruent. I apologize, I cannot think of any shortcut, but any less of a verbiage to use for that. Then, verbiage? Sure, why not? Why have a degree in math? And then when you have that Z, what else do we always say about that transversal? It's reflexive. Yep. So anytime you trace over that Z, you always call that part reflexive, because then it'll help you with the step then. So what do you have? J, G. Make sure you guys always are writing reflex prop or reflexive property. Make sure you put the word prop or property in there with it, and then mark it. And again, you've got two angles in a side. In this case, where's the side? In between. This is your angle siding. Yes, sir. No, because if you just do the parallel thing with the sine curve, it looks like it's technically a sine. If you're saying, I'm with you by doing this. With the arrows. Like that. Huh. Huh. Never thought of that. I'd hate to change it in midstream, but it's a good idea, but what if you accidentally mark the wrong angles? You know what I mean? I know. Let me mull it over. Let me think, all right? I like it. I like that one. It's not bad. It's not bad. Thank you. All right, this one starts out that you're given FG is parallel to KL. FG is also congruent to KL. And you want to prove F, G, K, and KLF. So, excuse me. Guess what we're going to do first? Our given. I know. That was a tough one. I know. Drawing your arrows. Trace. As you trace that, you will now have a backwards Z. Well, even though it's a backwards Z, it still tells you where the angles, which angles are going to be congruent to each other, because where it changes direction gives the alternate interior angles. So we know that angle GFK is congruent to angle LKF. And then you go to the next one. Not always will they be parallel and congruent. Just so happens they are in this case. And what are you missing? Very good, very good. You're missing the reflexive side again. And yep, this one side angle side. Now, I don't know if you noticed that this proof and the next one were the same. The only thing that was really different was the diagonal was different. Oh, we didn't do it. I don't know if you noticed it. It was just a mirrored image of it. Sorry. Jeez, that was awful. And you had AB. So again, go through what you know. Once you're set up with parallels, you write it down. You go through the Z. You trace it. If you guys happen to have a highlighter or something, or an extra color or different color, make sure you bring it around tomorrow. By all means, use it to mark your diagrams, especially if you have to figure out where something, if you've got like that first one we did where you had that, you're not sure where the triangles actually are occurring, or if you've got a Z you want to mark up. By all means, please bring something extra to draw on. Yes, sir. 703. That's right. Could you imagine having a test with 700 questions on it? I don't think you could literally fit it. The final doesn't have 700. The final's got like 40. Like nothing. Yeah, so, no, actually, I do believe I've mentioned on, I don't know, 12, 13 different occasions, how many questions we're looking at and all that, what styles. He's not even listening to me anymore. So this would have been B. You got your A, B, and C, D. I don't know if you guys are just when you do the parallel, if you're automatically doing reflexive. If you want, go for it. It's fine. But if you noticed these last two proofs, and I want to show you why this happens. Honestly, as you get going into these types of proofs, guys, they all look the same. That's one thing. But in the long run, there's only so many of them that you can do. It really is. Especially when we're dealing with just triangles. We're not dealing with like segment addition or angle addition style problems at all. We're just kind of putting them together. More often than not, it's a couple of progressions, a reflexive side, and go from there. Oh, excuse me. Do take a second, and I want you guys to try. I think it's 3. Four. Sorry. Take a second and start working on number 4. Because what I want to do today is go through a couple more of these. Number 4 is one that kind of looks like this. Now, I know we talked about ones that look like this via parallel. This one isn't necessarily parallel. Yes, ma'am. What's? Oh yeah, just grab the thing. I don't care. What are the letters? It starts A, D, B, M, A, C. Okay, so A, B, M, C. It's that, right? Yeah. Whatever. I don't have time to write passes. Now, one of the things I wanted you guys to see with this is that this is kind of a weirdly written statement. Okay? You have a whole bunch of information up front, and that information has its own progression stuff. Now, like I said earlier, when I do a lot of these proofs that come from textbooks and stuff, I don't draw in any markings that are already there. I want to be able to go back and put markings in. Okay? I'm not going to worry about it right now until I get further along to see where they're coming from. That way it's easier on me in the long run. So I believe the first one said AM is perpendicular to AB is perpendicular to CM. The next one says that AB was perpendicular to DB, and then it gave you CM congruent to DB, and then it was M is, yeah. There's a lot here. Midpoint of AB, and then it was proved your triangles. Now, before I go into my proof, I'm going to walk you through what I would do on my diagram, so that way I know what to do in my proof. Because all this stuff is progression anyway. Perpendiculars, progressions, midpoints is progressions. That way you remember where you're going to go. If AB is perpendicular to CM, what happens there? I don't want to say it's M, not angle M. I can't say angle M because there's 3 or 4 different angles here. I can say CMA is a right angle. I can also say that DBA is a right angle because of for those two. What do you know about right angles? Which means that they're all congruent. Okay. But in order to do that, first thing you'd have to say is that you have right angles, and then you say that they're congruent. Okay, progression, you've done it. I know then also if I'm looking at my diagrams, CM, DB, those are the same. And then the last one is that M is a midpoint. What's midpoint do? Cuts it in half. What's created? Are they equal or not equal? Yeah. Just by looking and walking through that, what are you going to wind up with? You're going to wind up with side. Okay. Just getting ahead of yourself by reading your given statement, you're able to know where you're going to have to go by marking the diagram in such a way. So this is that one that just takes a minute to write out. So we have AB perpendicular to CM given, and then AB perpendicular to DB is also given. Now, could I have split those two apart and said something about each of those right angles individually? Absolutely. But we knew that since there were two right angles formed from just one of those that one statement, it's okay to split them up. Because now I can say that angle DBM and angle CMA are right angles. Definition, perpendicular. Okay. Now, what do you know about all right angles? They're great. Okay. Take a couple minutes and finish that out. I just wanted to show you that sometimes when they give you two separate parts of perpendicular, it's okay to combine them if you want or set them up separately. There's no right or wrong on that one. I saw you kind of looking at it. Nice. Nice. What were the letters of the triangles we're trying to do? AMC, thank you. DB or BD? B. Okay. Yeah. I know it's just stuck in my contact. So yeah, I'm really bad about changing contacts out. I know I'm supposed to change mine every couple of weeks. It's like every couple of months. I can't do that. I've tried before. I've woken up and they've been like crusted over and just hit up my eyes. Solution and stuff, yeah. Now, if I'm not mistaken, the only other one that's I'm sorry. Do you see them all okay? I'm sorry. I didn't mean to cut ahead of you. The only other one that's on here would be number 6. The 6th one, I believe, has got the 2 segment bisectors. And I just want to make sure that you guys have the correct information on your progression sheet about what to do with a segment bisector versus the angle one. I know we talked about angle bisectors last. We're good? All right, cool, thank you. I know we talked about angle bisectors just the other day because I forgot to tell you about them. Oops. But we did segment ones though, right? Okay. So what happens in this one, and I'm not going to go too long on this one because I think you guys can kind of figure this one out. It's not terrible. You have, is it A, B, C, D, C's in the middle, thank you. And this is E then? Thank you, sir. So what they're giving you, it says that AE and BD bisect each other. So what I want you guys to think about is in that generic statement, is there anything that says that AE and segment BD are equal to each other, or are they congruent to each other? No. So a segment bisector does what to a segment? Cuts it in half. And it creates two congruent segments. Everybody okay with that? All right. So going into here, I then know that AC and CE would have to be the same. But I gave those guys one tick mark each, which means how many tick marks should I give the other one? Because I don't know that they're the same. Now, that one statement allowed me to set up two different sets of congruent segments, which is absolutely fine. Sometimes that happens. And then you just write it out. And this is definition of a segment bisector. What's missing? Very good. Vertical angles are missing. Vertical angles are missing. So as you notice it, mark it so you don't forget. And then when you label it, if I say angle ACB, what are the letters that have to match if I say ACB? ECD? Very good. Got to follow your tick marks. And that's really the trickiest thing about this, guys. I think you guys are, I mean, sounding wise, it seems like it's not as scary as it once was. Are the two triangles congruent to each other now? Because of what? Side angle side. Okay. Side angle side. Now, I know yesterday, or actually this whole week, I've been telling you there's going to be 5 different ways that we're going to prove triangles, and I wanted to try to get to it today, but honestly, we're going to be fine by holding off on that style, because I made sure, I didn't know if we were going to get to it or not this week, so I made sure not to put that 5th version of this on the quiz tomorrow, so you don't have to worry about it. We'll talk about it again next week, because tomorrow we'll quiz. On Monday, I've got some stuff for us that, you know how I've been kind of just looking at our given statements and marking the diagrams and figuring out how we're going to prove it through? I've got stuff for us to work on that looks like that as well, because eventually come Tuesday, we're going to be given something, a whole bunch of given statements, and then instead of proving the triangles, I'm going to ask you to say, prove angle A is congruent to angle E. So what you need to start thinking of is, well, first of all, in order to prove something, I have to show that I have triangles first, and then I can say something about the corresponding parts. So it's a practice in looking at your given statements, marking the diagrams beforehand, and then doing our proofs like we would normally. It's no big deal. Yeah, kind of. We'll get there. We'll get there. So tonight, what I want you to do, you've got 2 left on that worksheet from yesterday, and then on, I want to say it's page 277. I better check. I'd hate to be wrong. There's 2 more. There's 2 more on there. I'll collect all this junk tomorrow. Take our quiz. Like you guys have known, make sure you have a progression sheet. We've got the the 4 questions. It is all on your own. It's all on your own. I drew the pictures for you, but I did not draw any congruencies to the pictures. You'll have to do that on your own as you're going through like we've been doing, and then go from there, okay? I did, yes. If you guys want some more of those 3x3s, I've got plenty of them back here. Please help yourself. Please help yourself. There are plenty of them. Here you are. You're welcome. Yeah, preparing for quizzes that have proof stuff in it. I've said this before. A lot of times, one of your best bets is to rewrite your progression sheet because it helps you remember where you put stuff. It might help you read your handwriting better.
You just might as well say your names.
No shame.
Because hey, I know you should probably rewrite yours. So you can read it. It is a guys. It is a very common thing that it's not that you don't have the information on your progression sheet. It's not that you don't want to use it, it's just that you can't find it because you can't read your own damn handwriting. So, if you slow down and rewrite it neatly, spend more than 2 minutes on it, by all means, like I said, there are plenty of the blanks back there. Just crack the door open to you. Because we don't, just leave it all, open it all away. Otherwise, we're making new math problems. All right.